Welcome to Study Loop.
Okay, let's first go over the givens in the problem. So we're given that the mass of the bucket is 2 kilograms, the mass of the water is 10 kilograms, spring constant's 450, amplitude is 3 centimeters, so that's 3 times 10 to the negative 2 meters, and the change in the mass of the water with time is negative 2 grams per second, so that's negative 2 times 10 to the negative 3 kilograms per second. It helps to start with SI units. All right, the first part's pretty easy. So for the first part, we know the total mass equals 12 kilograms. And we're cutting the mass of the water in half. So we're taking 5 kilograms of water away. So our initial mass here, or the mass when they're asking what the period is 7 kilograms. T, the period, equals 2 pi square root of big M over K. This is 0.784 seconds. Part A is easy. Part B, not so much. So part B, we have to use a bit of calculus. So first, we'll write the period in terms of the sum of the masses. So 2 pi square root of the mass of the bucket plus 1/2 mass of water over K. They're asking how the period is changing at the point where half of the water is left in the bucket. So we need to take the derivative of this thing. dt dt equals ddt. I'm just going to rewrite this into a form that's easier to differentiate. So 2 pi mb plus 1/2 mw over k to the 1/2. All right, let's just start going with this. So we're going to take the 2 pi out. We're going to take the 1 over k out because that doesn't change with time. And we have d dt of mb plus 1/2 mw to the 1/2. All right, now let's do this derivative. 2 pi 1 over k to the 1/2. We take a 1/2 down from the square root, and we have mb plus 1/2 mw to the negative 1/2. Just the rules of differentiating an exponent. And then we have to do the chain rule. We have to take the derivative of the inside. Well, the derivative of the inside is just dm dt. The only thing that's changing with time is the mass of the water. So if we take the derivative of the inside, we get the dm w dt. We can plug in numbers for all of these things. So we'll plug in, I'm not going to write this out, but we'll plug in 450 for k. We'll plug in 2 for mb, 10 for mw, and the negative 2 times 10 to the negative 3 for dm dt. We get negative 1.12 times 10 to the negative 4th. And this is a weird unit, but it's seconds per second. So it's saying that the period is going down by 1.12 times 10 to the negative 4th seconds every second. Okay? So the period's directly proportional to the square root of the mass of the system, and there's a leakage of water. So the mass of the water is decreasing. The period of the system will be shortest when the mass of the water is 0. So let's figure that out. So this was part B, and now we're going to do part C right here. This happens when it's just 2 pi square root of 2 over the 450. So just the mass of the bucket, and this is 0.42 seconds.